We're now going to take time to work through some example problems. So let's look at the first example. We're trying to find our critical points. We're going to find the intervals of increasing and decreasing, and then we're going to tell whether our critical point is a relative maximum, a relative minimum, or possibly it could be neither. So let's look at the example of y equals x cubed minus 12x minus 5. The first thing we want to do is take a derivative. So if we start with the derivative, we're going to get that y prime would equal 3x squared minus 12. But remember, to get critical points, we want to know what would make that derivative either be 0 or undefined. Since our function is polynomial, we don't have to worry about it being undefined. So let's just look at 3x squared minus 12 equals 0. Now we have a couple ways we could solve this. Since we just have an x squared term, we could isolate the x squared and then take the square root of both sides. I'm going to actually do this one by factoring because you do that a lot with these type of problems. So I'm going to take out the 3 first and be left with x squared minus 4. And then I'm going to factor x squared minus 4 to x minus 2 times x plus 2. Now we know that if we are multiplying these three things together and we're getting 0, at least one of those has to be 0. Well, 3 can't equal 0, so let's set each of our parentheses equal to 0. And we get that in this first case that x could be 2, or in the second, x could be negative 2. So we've answered the first part of this problem, which was, what are your critical points? So we found where our derivative is 0, and we've said it couldn't be undefined, so our critical points would be plus and minus 2. So now let's continue. We know our critical points are 2 and negative 2. And we also know that our derivative, remember when we had it factored, was that f prime of x was 3 x minus 2 times x plus 2. So what I like to do to tell where I'm increasing and decreasing is I like to make something called a sign chart. And what we're going to do, now I actually draw these a little differently than they do in your textbook, so you can use either the way I do it or you can use the way the textbook does it. So I'm going to make a number line, and I'm going to label negative 2 and positive 2. And then I'm going to notice that what I've just done is I've actually divided that interval now, or that number line, into 3 intervals. I have this part from negative infinity to negative 2. Then I have the part from negative 2 to positive 2. And then the last thing is I have this part from positive 2 to infinity. And what I'm going to do is I'm just going to pick some values that are in each of those intervals, and I'm going to see what happens to my derivative. So I'm going to pick a number that is to the left of negative 2. Now I can pick any value that I want to, and I'm actually going to pick, let's say, negative 3. Now I could have picked negative 5, negative 700. Any number that's to the left of negative 2 would work. And then I want to see what happens to my derivative. So you have different forms of the derivative that you can use. I always use my factored form because I find it's easier to work with. Once you're used to doing this, you don't have to write down as much as I'm about to do, but you can if you need to. So what's going to happen if I take this derivative and I put in negative 3? All I care about is my signs. Is it positive or negative? Well, we know that 3 is a positive number. If I put in negative 3 times negative 3 minus 2, I get a negative. And then if I put in negative 3 into this part, I get negative 3 plus 2, which is a negative. Well, remember, we're multiplying those together, so if I do a positive times a negative, I get a positive. Then I'm going to pick a number between negative 2 and 2, and I'm going to pick 0, since that's a nice number to work with, and I'm going to go back and I'm going to substitute into my derivative. So again, we know 3 is positive. If I put 0 into the next part of the derivative, 0 minus 2 is negative, and then 0 plus 2 is positive. But if I multiply a positive times a positive, I know that that is negative. Then I pick a number that's greater than 2 or to the right of 2. So let's pick positive 3. And we'll substitute that into our derivative. Well, 3 is positive. 3 minus 2 is positive. And 3 plus 2 is positive. So that turns out positive. Now we have on our sign chart what's happening to our graph. Here is, and I need to label this, we'll call this F prime. Here is the point or points where F prime is positive. Well, remember we've already discussed that when F prime is positive, your graph was increasing. So let's label our increasing and decreasing. So if our graph was, or our derivative was positive, we were increasing. So everything from negative infinity up to negative 2 would be increasing. Then the next thing our sign chart does is it changes from to negative. So that's the points where we were decreasing. So everything from negative 2 to positive 2 was decreasing. And then the last part of our sign chart tells us that we were increasing again. So we can add that to our interval. So everything from 2 to infinity would be increasing. The last thing we need to do is to determine whether these critical points were maxes or mins. One of the things I like to do with my F prime sign chart is kind of just sketch in what's happening to your graph. So remember, we said that right here when our derivative was positive, that our graph was increasing. So I'm just going to kind of lightly sketch in, oh, this was increasing. Then the graph or derivative was negative, which means my graph was decreasing. And then the graph or the derivative turned positive, and so we were increasing again. And notice that that was the intervals we came up with here. So now by looking at our graph on the sign chart, we can find our maximums and minimums. I will point out that if this is your F prime sign chart, then most of the time, especially if this is a polynomial, that's what your f of x is going to look like. If you sketch in your increasing and decreasing, that'll be a rough sketch of what f of x would look like. Now that's not always true, but it does work a lot of times for your polynomials. So then we can look at negative 2 and notice that our graph went from increasing to decreasing. So we actually have a relative max at negative 2, and then we could go back to our original function and get our y point. Now remember that the original graph we were working with was x cubed. Let's see if we can get this to right. So we originally were working with, we'll write down here, x cubed minus 12x minus 5. So if I put negative 2 into this original function of f of x, not into our derivative, then I'll get my y value for negative 2 to be 11. And there's where my relative max is located. Then we also have a relative min. And if you'll look, our graph was decreasing. So we're again looking at this part where we were decreasing and then increasing. So that tells me that I have a relative min at positive 2. And then again, substituting that into my original f of x function, I get that my y value was negative 21. So that's where my relative min would be located. It's really important that you keep straight where you're substituting points into. If you are looking for a y value, you have to always go back to your original f of x. If you're going to do a sign chart, you're substituting into the derivative. So when I picked my points here on the sign chart, at negative 3, at 0, and at 3, I substituted those back into f prime to determine my signs. Now, later in future videos, we're actually going to look at how to take these points and now sketch my graph so that I know what the graph of x cubed minus 12x minus 5 looks like.